Hello, everyone. Thank you for joining us. My name is Vlad. I work as a BI technical lead at Mindit, and I'm joined by Eileen, Senior Solutions Engineer at Databricks. We're here to talk about how a solid data architecture can build trust in your organization, enable everybody involved to have a clear picture over the growing informational system, as you all are aware. Eileen, if you have any word to start,
Yeah, I
if
just
not, we
also,
can.
yeah, just want to say hi to everyone. I'm super glad to be here with Vlad and also super happy that you joined us for the session. Governance in action. I think governance is a super important topic. It's basically applicable everywhere. So yeah, definitely pay attention. I think we have a lot of valuable insights to share with you about the challenges and solutions that we can provide. So I hope that you can take a lot of valuable information out of this webinar.
Yeah, the time is short, but we do have a lot of information, so attention is key here. Okay. Before we dive into the features, the tooling, and all that stuff, I want to take a step back, talk about something every organization struggles with, that being trust in data, either your data or someone else's data. Every organization wants to be data-driven, but in reality, trusting data is incredibly difficult nowadays. Data comes from many systems. It's transformed multiple times. Ownership is unclear of data sets, and definitions change along the way, And the moment people start trusting the data, stop trusting the data, sorry, everything kind of slowed down. Decision making, delivery, innovation, you name it. That's why this session is about data governance, not as a compliance exercise, but as a way to restore trust, transparency, and confidence across the organization. To help us with that, Eileen will walk us through how Databricks and Unity Catalog addresses these challenges in a practical and scalable way. So Eileen, let's start at the foundation. What does data governance really mean in the context of modern data platforms, and how does Unity Catalog approach this problem as a whole?
Yeah, thanks, Vlad. So, as Vlad said, um, in everyday life, when I work with customers, a problem that we often see is that it's really, really difficult to scale governance. Governance in a small scale, usually it's doable, and many companies, they do have some sort of governance in place. But when it comes to bring governance, like a unified governance throughout the whole corporation and to scale it, it's really, really difficult. And some of the reasons are already mentioned by Vlad. Like, for example, you have fragmented data sources, right? Like companies still have on-prem legacy systems, but at the same time, they move to cloud, sometimes even multi-cloud, a lot of different platforms that they have to combine. And also nowadays, we're not just talking about relational databases or tables anymore. Log files are really important. You have like all sorts of files, big data, unstructured data. Now machine learning AI models are super important. Everyone's training their own models, how to bring this into your governance. Also, it's not about code anymore. You have different artifacts. Like people use notebooks. They use, yeah, of course, like code, but also notebooks and queries, and how to govern different kind of assets is also something that is usually not super simple. And also how to deal with different data formats, right? And these are questions that we see at every customer. So maybe it's a relief for you to hear like everyone's struggling with it. And this is also something we discuss oftentimes on a CIO level with different customers of ours. And that's the foundation of today, like why governance is so difficult, but also at the same time, it's super important. And to just setting the scene for today's webinar, I want to shortly revise on Databricks Data Intelligence Platform. So this will not be the focus of today, but still, if you're looking at this architecture, you can see why governance must be a foundation of your data platform. Everyone's now talking about AI and agents or having some fancy reporting dashboards, application apps built on top of their data platform. But the success of it highly depends on the foundation that you build. And Databricks, we're a proponent for an open and unifying data platform. And at the base, we have like open data formats, delta tables, iceberg tables, Parquet files, etc. That is accessible by everyone and by all platforms. And on top of that, you need a unifying open governance layer. So in the case of Databricks, it's called Unity Catalog. It's Unity Catalog sends the benchmark for open and collaborative data platform or data governance platform. And it comes with a lot of features that simplifies data governance for you as a customer. So when we look at the details of Unity Catalog, you can see that it, like compared to traditional catalogs, which only usually covers the security part, for example, data access control and data auditing, and also usually only covers assets like tables. Unity Catalog covers different capabilities on top, like data discovery, data lineage, data quality monitoring, business semantics, cost controls, etc. And we will deep dive today on some of these capabilities. On top of that, Unity Catalog also covers all different kind of artifacts and assets. So it's not only about tables, but we, of course, also materialized views, machine learning and AI models that you train, files and notebooks and dashboards. And Unity Catalog is also open. So you can federate to different, to external systems, to different, to the external catalogs as well. And also it offers an open API where you can use a REST API access to access the data governance layer from any other external tools. So this sets the foundation for today. And I would suggest we deep dive already to our first topic, which is data lineage.
Awesome. Thanks, Eileen. Well, one thing that really stands out to me is that trust doesn't come from policies alone. It comes from understanding governance as a whole. Like you mentioned it. It's a full concept that you can get behind. And as we all know, in most organizations today, data flows through multiple layers: raw ingestion, transformations, curated data sets, semantic models, you name it. And yet very few teams can clearly answer a simple question, which is, where did this number actually come from? That's where data lineage becomes critical. It gives us visibility into how data moves and evolves across the entire architecture. Eileen, can you walk us through how Unity Catalog and Databricks as a whole handles data lineage, and why is it so important?
Yeah, data lineage is really important for data transparency, right? Like you want to see how the data flows throughout your organization. And it's like data lineage is also something that most customers already have in place. Like everyone has heard about data lineage. It's not super super new. Like it's not a super new concept, but it's quite familiar with most people already. But what I have experienced in the field is that oftentimes it's still quite manual. So people have to like manually define, hey, this is the successor of a data set. This is the predecessor of a data set. How are like the different tables related? This kind of information, it does not scale when you have to maintain manually. It does not scale for a whole company. So what Databricks offers, which is really convenient, I think, is an automated way to create lineage. And this comes based on the advantage of Spark, right? So what happens is you don't need to care about lineage. It happens automatically in the background. So how does it work? You run code, or you run like some ETL pipeline code, you run some SQL query, and usually like and Spark in the background always calculates a compute plan. Like how for this before it runs like this is distributed computing on different clusters, it always has to come up with a plan of how to read, map, and combine the data and the tables within the data. And then based on this plan that is calculated, it's the plan is logged, and all the metadata is extracted. And we have something called a lineage service. And this lineage service analyzes the logs from Spark Compute and also pulls the metadata from the code execution. And then it creates a column and table level lineage automatically for you. So this is a dynamic way of creating lineage, and there's no way you can miss something, because everything that happens on the platform, everything that runs through a compute, it's logged, and then it's analyzed, and then it's displayed as data lineage. And also, it's super interesting that it comes even on the level of a column lineage. So what I often see is only table level lineage, where you can see, okay, these tables are somehow combined together, but on Databricks and Unity Catalog, you can even see how columns are related to each other. And the results can be both displayed in our UI. So you just log into the workspace and then you see the lineage graph. But you can also export it via API to external catalogs. So we support all the common catalogs like Colibra, Alation, Purview from Microsoft. These are all compatible with the Unity Catalog data lineage service. Yeah. So yeah, just to summarize, with Unity Catalog, you don't have to do manual lineage maintenance, but it creates automatic lineage for you in a dynamic way, and it all happens at runtime. So this is also quite helpful, and you can even inspect like looking back the time frame that you want to look at the lineage, because it considers everything that access the data in a way that they are dependent on each other. So you can inspect like, oh, show me the data lineage from the computations that within the last 3 months. And then you will see how it will show you how the tables are related and which notebook or tables access which table within the last 3 months. And then you can also like show me the last 2 weeks, show me the last year. And depending on the time frame that you choose, you would see also different dependencies between the tables and artifacts, and it's a dynamic way to show data lineage, which is quite unique.
Thanks, Eileen. That's a lot to take in. I can pitch in here. So we can trace data end to end, understand discrepancies, and see how data sets are built. Just as a short definition, this feature is embedded into Databricks, keeps track of everything automatically, which is kind of nice. I can tell you from personal experience that this feature quickly becomes paramount in a big organization. At Mindit, we are working with one of the biggest retail companies on this side of the globe on a data warehousing project in Databricks. With data that supplies tens, if not hundreds of reports, imagine having to trace a data point through thousands of tables without data lineage. It's not fun, I can say that much. And most people in the engineering world will agree with me. But visibility alone isn't enough. Knowing where data came from doesn't guarantee that it's complete, fresh, or even correct, accurate. In other words, Lineage tells us how data flows through the system, but data quality tells us whether it can be trusted or not. So let's take a look at some of the key features an organization can benefit from. Okay, you can take it away, Ken.
Yeah, sure. So yeah, super well summarized. So data lineage is not enough usually especially when it comes to production workloads. You need also data quality monitoring and actually like real time, because especially when you do like development, you can still check on the data quality manually, like with EDA analysis, etc. But when it comes to production load, you need some automated way to track, are the data refreshed every day? Is the data complete? And this is something like we at Databricks, we have a feature called Lakehouse Monitoring. It's part of Unity Catalog, and it comes with different capabilities on different levels. And I want to focus on 2 capabilities, especially within the Lakehouse Monitoring. One is data quality monitoring, and one is data profiling. So data quality monitoring happens on a schema or database level. So a database we call schema, but people usually understand like this is like on the level of a database, and under the database you have different tables. And on the database level, you can enable it. It's just like one toggle. You can just like activate data quality monitoring for this database, and then everything comes out of the box. It's kind of a managed service for you. And what it does is it automatically detects the data freshness and completeness for all the tables under this database. So I usually advise it for customers to run on at least production level databases. You don't need to do it for dev or QA testing database. Usually these because it comes of course with a little bit of cost, right? Like you have to run jobs in the background to track the freshness and completeness, but you need at least it to run it on production database to ensure that you get notified when data is not updated. And this means that it offers you like a scalable quality monitoring, and offers you actionable insights out of the box. Just really simple. You just activate it for database, and then you get 24/7 monitoring out of the box. And then one level below, when we look at table level, we have something called data profiling. So data profiling, it's more monitoring on the column level. So what it does is it calculates regularly all the statistics within the columns of a table, and then it calculates drift. Like it can detect anomalies and drift in data. So if, for example, if suddenly a column just get null values instead of expected values, you will get an alert. Or suddenly if the data is drifting away, like you have the distribution of the data within one column is changing, then it will also alert you like, hey, I think this data is, something's wrong, there's drift in data, please take a look. So yeah, I brought some screenshots to show how it can look like. So for data quality monitoring, it's a really simple setup, and it comes out of the box kind of a dashboard that tracks. Here you can see like it tracks the freshness of the data. For example, you have data that gets updated daily or every 6 hours. It will it's powered by AI, so it will detect a trend. So okay, normally data is updated every 6 hours, and then if somehow a job fails and data is not refreshed, it will send you an alert. The same with completeness. It will detect like the trend of the data volume increasing. For example, if you have a incremental load and every day you get 3,000 rows of data ingested into the table, and suddenly the job didn't finish and the data volume does not change, then it will also detect that the data is not complete and something might be missing. Or even like also if the job runs through and only partially of the data, like somehow only 1,000 out of 3,000 rows were ingested, it will also detect that something's wrong and you'll get alerted. This is what data quality monitoring looks like. Let's look at data profiling. So at data profiling, you can set up monitors for all the different kind of tables. It covers like all the medallion architecture, bronze, silver, gold layers, tables, but also you can run a monitor on time series. So time series is interesting when you want to detect drift in data. And also you can run it on views, streaming tables. Also quite often used is feature tables for machine learning models. So if you want to detect changes in features used for the machine learning training, then it's also super important to know, because when the features change, your model outcome will change. The same, you can do it for model inference. So the inference table, you can also run a monitor on top. And each monitor will auto-create a dashboard to show you all the metrics and statistics. It will create a profiling data table and the data drift table. So these are like basically log tables that contain all the statistics values. So you can run analytics on top. And of course, you can set also alerts. Like if you specify, okay, if the drift is beyond that threshold, send the alert to me. So this is the main features within the lakehouse monitoring part. I hope this this was insightful, and in my opinion, these are tools that basically everyone needs when you run a production workload.
Awesome. Thanks, Eileen. What I like about data quality in Databricks after your presentation, mainly because I saw some of those graphs, is the fact that anybody can extract value from the system. Like the feature is not isolated to only engineering teams. The business can translate precisely what the data quality means in Databricks. They have the graphs, they have all the information needed on any table. So anybody can take something from this. You don't have to rely only on the data engineering teams. So that's a plus in my book. Okay, so now we have visibility into how data flows and confidence that it's reliable with data quality. The next challenge many organizations face is understanding what kind of data they actually have within their system, especially when it comes to sensitive information like PII, for example. As regulations keep evolving, data volumes keep growing, and manually tracking sensitive data simply doesn't scale. And let's be honest, nobody likes to maintain a manual process. Eileen, can you show us how automatic data classification and governed tags help organizations?
Yes. So when talking about especially PII data or like data, personal data, we often see that it can be a blocker for data and AI adoption within companies. So what often happens is nobody, like, people are scared to take responsibility. You know, like in case that there's a data breach, then nobody wants to be responsible for it, because it, like, you know, everyone knows, like also with the in EU, like GDPR, we have all kind of compliance rules, governance rules, and you have to make sure that nobody accesses like data that could contain PI data, and people then are, let's say, shy in sharing the data. So oftentimes departments, they create their own database, data assets. But then when it comes to like, oh, can like a neighboring department or another division access the data? They're like, I don't know what to do with the data. I don't want to have the responsibility in case there are some critical data inside of it. Then, and people usually, if you don't know, if you don't have the transparency of what data is in your data asset, then they cannot protect and they cannot share the data. So this is a huge block in adoption. And that's why we are offering now like an agentic data classification. So it's called agentic, but basically it's also like an automated way of running analysis on top of the, on top of all your tables and data assets, and then automatically detect PI data. And for that, currently, what we offer is like out of the box 16 types of PI data. Here you can see on the picture, for example, email address, social security number, IP address, phone number, etc. And then if you enable data classification on top of your catalog, it will run regularly jobs to scan the metadata, but also the data, like example data, to see, hey, is like our PI data existing anywhere in your database? And then it will list all the findings that it has, and then also you can enable some access control policies on top of it. So we will deep dive into this later on. But here I just want to show how it looks like. It's really simple. It's also just one toggle, you activate it, and then it will scan for PI data automatically and run scans. And it ensures that everything is like audit ready. So it will log all the activities from data classification is logged, and all the findings are also logged. And if we are talking about data classification, we also can like talk about governed tags. So if you find some PI data, you need to tag them so that you can run rules on top of them. Governed tags is a feature that you can use to define your custom tags. So for example, here you can see we want to create a tag called sensitivity, and then you can also define allowed values, like for example, internal sensitive or commercially sensitive. Oftentimes companies use this kind of governed tags for confidentiality flags, like something is highly confidential or only confidential, etc. So that by specifying, for example, allowed values, you make sure that everyone use the same term. Everyone use the same values. People not not just like free floating, writing some random values into the text, but everyone's using the same same classification. And you can use it for different kind of use cases. So for example, tags are used for discovery. If you want someone looking for specific data, then you can use the tags to find them. If discovery also of PI data, for example, then also use it for governance compliance. So by tagging the data, you can then have some kind of fine-grained access control. So here it's called attribute-based access control on top of the data. You can simplify like auditing or classification. And then last but not least, you can also use the tags for budgeting. So you can track the cost attribution of everything that happens on the data platform, what is spent on which kind of data. So sometimes people also use the tags for cost center or business division tagging to say like, okay, for example, HR, everything that is related to HR gets an HR tag, and then you can use the tag to determine how much is spent on the HR data. Yeah, and as mentioned, yes, as I just mentioned, there's a like a natural work flow to the fine-grained access control, so which is the attribute-based access control. And can I take this?
Yes, please go ahead.
Yeah.
Keep going. Keep
Okay.
going.
So I just follow up with this topic because it all belongs together, right? Like you have the data classification, you have the governed tags, and then the rational next step would be to utilize some kind of fine-grained access control. ABAC, so attribute-based access control, what is it? It's access control that is conditional based on properties of the user, resources, and requests. So the data access is basically determined by who the user wants to access which data, and then based on this information, it dynamically calculates which type of data or which data the user can see. So it usually comes in a 3 steps approach. In the step 1, some data stored, or also in this case for data classification, some AI can tag the columns and tables. Like for example, oh, this column contains email address, this column contains social security number. And then in the second step, usually a governance function comes in, like a governance admin, and then they define like, okay, within our company, we have the rules that only these group of people can see the social security number of this table, or like of some users, and then or customers. And then in the first step is when the data retrieval or the query actually happens. In this case, for example, a data analyst wants to access a table, but this data analyst does not belong to the group of people who have access to social security number. In this case, he or she can only see like a mask version. So it's only like everything is like basically masked, and you won't see any raw data. And how does it look like? So here, for example, so attribute-based access control, it comes currently in 2 different forms. You can both have column masking and row filtering. So column masking is usually used for when you want to limit access to PI data. So for example, email addresses. For email address, usually you can also mask, for example, the name, like the first part before the @ and then for example, keep like @gmail.com is visible, but you can mask everything before, like you can have some regex expression applied, or you just mask like the whole thing, like the phone, the mobile number, or the name, the address, everything can be masked. Row filtering is more applicable if you want some category based filtering. So if you say, for example, an analyst in the US is not allowed to access on customer data in Europe, then usually you have a column which is like location or the address of the customer, and then you can have a row filter in place that says like, oh, people within the group of US analysts, they cannot see everything. Like for them, but please filter out everything that is within the EU. So these 2 are super powerful, and within like using column masking and row filtering, you can basically cover all the common use cases you see within a company when it comes to data privacy control. Yes. So yeah, that's about it. So what's your take on it, Vlad?
Awesome. Thanks, Eileen. So let's wrap everything up. What we've seen today is that data governance isn't about slowing things down or adding more process on top of everything that we do. It's about enabling teams to work better. So I've seen this firsthand when governance is built into the platform instead of layered on top with more processes. teams actually move faster because there's less uncertainty, far less rework. You don't have to always go back and check, even if it's policies, even if it's lineage. So when you combine data lineage, data quality monitoring, data classification, and fine-grained access control, people start trusting the data. It's inevitable, and once the trust is there, conversations change. Like teams stop asking, "Is this correct?" when referencing data, and start asking, "What can we do with this?" Because they trust it. That shift makes a huge difference in how quickly organizations can deliver value. So that is why Unity Catalog has been so, and Databricks as a whole has been so impactful for us in practice and Minded. It turns governance into a solid foundation, and it supports analytics, reporting, and even AI initiatives. And it doesn't act like a blocker to the engineering team. I'm speaking for the engineers in this, and it's really helpful. Everything that Eileen presented, we have used to a certain extent in many of our projects, and I can guarantee you it's helpful. But I don't have anything to add on top, Eileen. That was pretty well detailed and explained. We have time for some questions, but before the Q&A session, take a moment to fill a feedback form. Someone from Minded will send it. It just helps us tailor these experiences better on what people need to know, what they're interested about. Okay, I see we do have some questions. Let's take them one by one and just jump in, Eileen. If you want to take it. Let's start with the first one. Can we see lineage at column level? I can take this. The short answer is yes, and the long answer is you can track each table. Each table contains successor and predecessor data of what happened to that table throughout the flow. And within that lineage graph in Databricks, everything is in the UI, so it's easy to see. You can select one column in that table, even if it has 200 columns, it's tracked for every one of them. And you can see that column from the point of ingestion, from the source until the reports, or even for after the report. It depends on what you do with the data. So yes, you can track column level lineage just as well. Hope that that answers your question. Let's go to this one. This is interesting. I think you should take this, Eileen. Gerd asks, does the lineage also show from which external storage the data got ingested? Like, for example, if you have query federation to an Azure SQL database, does it show the details of the source?
So it depends is the answer. So in Unity Catalog, we have something called external locations. So if you specified external database as an external location, or if you specified some paths like storage paths as an external location and external catalog, like if you basically, if it's defined in Unity Catalog as an external asset, then it will show up in the data lineage. If you just have like a notebook and you use some JDBC connection in the code to connect to some external database and then extract data, or you read some like this, then it's not tracked in the lineage. So because in order to show it in the lineage, it must be governed by Unity Catalog. So everything that is an external location or external catalog within Unity Catalog can be showed. And also if you use some basically like we have a marketplace, for example, we have Fivetran as a ETL tool that you can use. Like we have a lot of, in the marketplace, we have a lot of external ISVs also offering like ISV offerings, for example, Fivetran to ingest SAP data on this kind of things, or Oracle databases. And if you use some of the managed offerings, then yes, they will also be shown in the lineage.
Awesome. Yeah, that was a good answer. And I see here, I see a question that I think both of us should answer one by one to offer like a different perspective, one from the engineering and one from solution architect side. Someone asks, in practice, what are the visible signs that an organization lacks data trust, and how do these issues typically impact analytics and AI initiatives? Well, I'll take it first and I'll be short. You know that moment when a lot of your teams or separate departments start creating their own spreadsheets, they start creating their own reports, and interpretations of the data, that's when data trust is at risk, and someone should intervene, because the moment your engineers start interpreting the same data differently when it's not needed, if it's not a specific use case, that data should be taken differently. When you see 10 Excels laid out differently in a different format, but on the same data source, that's an issue sometimes, most of the times. So that's I think it's a sign that you need to look at the data governance and get people to trust in the data. What do you think, Eileen?
Yes, definitely agree. Also, what I think what are first visible signs is that there's protectionism going on. Like as I mentioned, when people are afraid of taking over responsibility or ownership of the data, and they are scared to share the data with others within the company. Usually, this is like a huge red flag. That usually it means that something like the data quality is not ensured, because people are scared to share, because they know like probably there's not no monitoring in place, there's no quality insurance in place, no SLL. They don't want to offer any SLAs, right? This is one sign for me. Another sign is that when you have a lot of duplicated data. So usually what I often see what often can observe is that data gets copied everywhere. People don't know where's actually the ground truth of this data. And this comes with lack of transparency. Like you don't see the lineage. Like if you don't have a proper lineage in place, you don't know where this table actually comes from. Then people like to, if they don't trust the data from the actual ground truth source, they make their local copies of the data in their local database and then run like projects on top, or they fork somehow their own fork of the data and then enrich it with other data. So and then you have the same data actually duplicated everywhere, and you have a bloat and a huge data volume. This is usually also a red flag. What I can observe. And yeah, let me think. Yeah, I think that would be it, like as an addition to what Vlad has already said.
Yeah, I totally agree. There always will be signs that the organization or specific department doesn't trust data that it's using. You just have to look closely at what value they are extracting from it and how they are extracting it,
Yeah.
I hope this answers your questions. Your question, sorry. I see Hans. Do we have time for one more question, which is, isn't data quality the responsibility of data engineers? Well, what do you think, Eileen? I think we're past that point now. I think it evolved. It should be like a team effort. Everybody should be responsible of the data quality. I mean, yeah, data engineers play a big role in the technical sense, but I believe
Yes.
everyone involved, now that everybody can see data quality in Databricks. And I think you can spot errors before making decisions like that. Everybody has an eye on it. It shouldn't be just one department's responsibility, right?
Yes. So in a I would say close sense, yes, data quality is definitely the topic of a data engineer. But also data engineer can only ensure that much, right? Like data engineer can ensure like the schema is correct, or like the data that comes in fits to the schema. It can ensure that the data is like the freshness is there, complete is there. But sometimes, for example, data engineer, they don't look at data drift. So there's like, if you usually you have some data engineers and you have some like data scientists that trains the models. And then usually data engineers like things like feature engineering, and then also making sure like model drift, inference data drift, these kind of things usually are monitored by the data scientists. And then it's really, in some cases, it's really hard to say, where do I draw the line? Like who is responsible for what? So I would say like with like the features that we presented, it's it's kind of it's making everyone's life a little bit easier, right? Like if you think if you want to have monitoring and quality monitoring in place, you can just enable it. And then someone has to be responsible for tracking the outcomes and someone needs to be alerted. But yeah, it depends on the application, I would say, who is responsible. Sometimes it's also the data governor who is in some organization. You have like a data governance function in place, and then these people are the ones who has to also ensure that the data quality is met. Yeah.
Yep, no, that's a good answer. I hope it answers your question, Hans. Okay, I see that's pretty much it. With that, I want to say thank you, Eileen, for this, for the insights, and thank you for all of you who joined us today.
Yeah, thank you for joining, and thank you for a lot of questions. It's
Yeah,
really nice that people
people
ask a
seem
lot of
interested.
questions.
Yeah,
Yeah.
yeah, we're happy to spark that interest for you. We really appreciate your time. Hope we gave you some practical ideas you can take back to your organizations, your teams, maybe start doing some of these things or working on top of them. So yeah, stay tuned as Minded has more webinars lined up, and make sure to follow Eileen and Databricks. They do some awesome stuff.
Yeah, and also feel free to connect to me and Vlad on LinkedIn. And also if you have some follow-up questions, you
Yes,
can
of course,
contact us anytime. Yeah.
we're available.
Yeah. Just one addition. I just saw like one of the questions someone asked about scaling AI use cases and governance capabilities regarding transparency, compliance, and trust in AI. So we didn't deep dive into like this AI use case today, but Unity Catalog and Databricks, we offer also governance, including AI, like the UI AI use cases, including model governance and also model lifecycle, access control, etc. So
That sounds like another webinar.
yes, so maybe we do a follow-up.
Yeah.
Yeah.
Okay. Thank you again, guys.
Yes. Thanks, everyone.
Thank you, Eileen. This was awesome.